So when we have two proportions, that means we'll be using sample data from two independent samples to test a claim made about the difference between the two population proportions. So we'll call these P1 and P2. The requirements for this are: 1, we have to have proportions from two independent simple random samples, and 2, for each of the two samples, the number of successes is at least 5 and the number of failures is at least 5. And this is a very simple way to determine if the criteria are met or not. Now, our notation for two proportions is going to be a lot like the notation for one proportion, only now we have two populations and two samples, so we use subscripts to tell the difference between them. So for population 1, we have P sub 1, which is our population proportion, N sub 1, which is the size of the sample, X sub 1 is the number of successes in the sample, and P sub 1 hat is X sub 1 over N sub 1, which is the sample proportion. And for population 2, we have similar notation, when we have subscripts of 2 instead of 1. So we have P sub 2, which is our population proportion, N sub 2 is our sample size, X sub 2 is the number of successes, and P sub 2 hat would be our sample proportion. Now, another thing that we have to use in the formulas for two samples is a pooled sample proportion. So when we talk about the pooled sample proportion, this is just something that goes into our formulas, and this is basically taking our two samples and putting them together and getting an overall proportion using both of the samples and both of the sample sizes. So we call this just P hat without a subscript. And the formula for this is, again, on the top we just add the number of successes from each of the two samples. On the bottom we add the two sample sizes, and then we divide those two things. And our test statistic, when we're doing two proportions, this is a z sub naught. Again, when we're dealing with proportions, we're going to use the standard normal distribution. So we can tell that by the fact that we have a z here. So on the top we have just the difference between the two sample proportions, so P sub 1 hat minus P sub 2 hat. And on the bottom, underneath the square root, notice that we just have a P hat in here, which is our pooled sample proportion. So this is our pooled sample proportion. This is 1 minus that pooled sample proportion. And then here we have 1 over the sample size for the first sample plus 1 over the sample size for the second sample. Now remember, in the last chapter we talked about hypothesis testing and we went through those 5 steps. We're going to have the same 5 steps for these hypothesis tests. So step 1 is to determine our null and alternative hypotheses. Step 2 is to choose a level of significance, alpha. Step 3 is to compute our test statistic. Step 4 has 2 parts, finding the p-value and then determining the initial conclusion. And step 5 is to state the final conclusion. Now step 1 for this is going to be a little bit different just because we have 2 parameters to deal with. So again, we're going to start out by writing down the claim or the statement being made in a complete sentence. And then we're going to translate that into an alternative hypothesis. So we're going to use P sub 1 and P sub 2 to represent our 2 population proportions. And then again, we're going to decide what inequalities should be used. It has to be either a less than, a greater than, or not equal to. And to figure this out, think about how the population proportions are compared in the claim. And then we're going to write all our alternative hypothesis in symbols. So first write the inequality with P sub 1 on the left side and P sub 2 on the right side. So you're either going to have P sub 1 is greater than P sub 2, P sub 1 is less than P sub 2, or P sub 1 is not equal to P sub 2. And the reason that we start with this is because it's easier just to think of how the 2 population proportions are comparing in the claim. Now once we have our alternative hypothesis written this way, For several things, including StatCrunch, if you're going to use that, you need to have it written so that p sub 1 and p sub 2 are on the same side of the inequality with a 0 on the other side. So once we get it in this form, then we're just going to subtract the p sub 2 from both sides so that we have p sub 1 minus p sub 2 on the left side and 0 on the other side. That's not going to change our inequality. So again, once we have our alternative hypothesis, then we can write our null hypothesis just by replacing that inequality with an equal sign. So let's just do some examples of writing hypotheses. First example, an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. First we'll write the claim as a complete sentence. So the percentage, and remember percentage means proportion, of urban households with internet access is greater than the percentage or proportion of rural households with internet access. Now we want to translate this into an alternative hypothesis. So we do have to decide which our two populations are. The easiest way to do this is to make population 1 the one that's mentioned first in your claim, just because it's easier that way to translate it into an inequality. So let's say that our two populations are urban households, population 1, and rural households, population 2. So we're going to use p sub 1 and p sub 2 to represent our population proportions. And what inequality should we use? If we look at our claim, it's talking about the proportion of urban households with internet access being greater than the percentage of rural households with internet access. It actually uses the words greater than, so that would translate to a greater than symbol. Okay, so we would first write our alternative hypothesis as P1 is greater than P2. And then we're going to rewrite it by subtracting the P2 from each side so that we get P1 minus P2 is greater than 0. So there is our alternative hypothesis. Then our null hypothesis is just going to be this same thing with the inequality replaced with an equal sign. So it's going to look like this. Let's do another example. In clinical trials of a new vaccine, monkeys were divided into two groups. Subjects in group 1 received the new vaccine, while subjects in group 2 received a control vaccine. Drowsiness had been noted as a possible side effect of the vaccines, and researchers were interested in whether a different proportion of subjects in group 1 experienced drowsiness as a side effect than subjects in group 2. Again, we want to write our claim as a complete sentence. So, the proportion of subjects in group 1 that experienced drowsiness was different than the proportion of subjects in group 2 that experienced drowsiness. Now, to translate this, again, we're deciding what our two populations are. Since we already have it up here stated as group 1 and group 2, it would be easier to make those match. So, let's say that our population 1 is those receiving the new vaccine, because that was group 1. And those receiving a control vaccine would be population 2, because that was group 2. And what inequality should we use? The claim just says that P1 is different than P2, so this translates to a not equal to. So we would start out by writing our alternative hypothesis as P1 is not equal to P2, and then we'd subtract the P2 from each side to get P1 minus P2 is not equal to 0. So there's our alternative hypothesis, and there's our null hypothesis that we get by replacing the inequality with an equal sign.